Hey, welcome back to Fat Mama Physics. We are going to do an example with using Fnet and free body diagrams on a question. In the first part of the video, I am going to do the example myself, and the second part of the video, I'm going to give you a chance to try while me playing the solutions on Fast Play. Any point in time, you're welcome to pause the video and just try the question and play a little bit until you get stuck and then play the rest of the video. Okay, so here I get started. Example 1. Two people are pushing a stalled car in this diagram. The mass of the car is 1850. One person applies one force to the car, which is this one, while the other person applies this force, 395 newtons. Both forces act in the same direction. There's also a third force acting on the car, but in the opposite direction, backwards, probably like friction or something. Find the acceleration of the car. So that's what we're asked to do. Before we even start doing any calculations, always draw a free body diagram. So let's do that one first. You have a car, which I'm just going to draw a box just because it's easier. Put a dot in the middle. One force acting forward is the 395 newtons. That's actually it's called an applied force because some sort of contact force. Person is pushing, pulling. We usually call that. Okay, the next one we have is a smaller force, also an applied force. So I'm going to draw a shorter arrow, and this one is 295 newtons. Last but not least, we have a backwards force acting on the object, and it's pretty larger than both of those, 560. So I'm going to label this as the friction force, 560, probably some sort of friction acting on the car, some sort of resistive force, okay? So there we go, that's our free body diagram. There are other forces you might think do apply to this car, such as the force due to gravity, which is probably very big, as well as a reaction force coming from the ground that keeps the car from falling through the ground. Yes, you're right, they do exist, but they will not be applied in our question because we are only considering we're only considering the horizontal forces. More importantly, what I'm going to do, I'm going to label the forward direction as our positive direction because that is important when we consider the direction of the forces. So next up, we are ready for calculations. We do know that the Fnet is equal to the mass times acceleration of the object, and we do know the mass. We need to know the Fnet before we can calculate acceleration. So we need to calculate Fnet first. Fnet is the sum of the forces. So all of the forces added together on our system in one line. So in our horizontal line in our case. If we had if we cared about the vertical forces, that would be another question. So Fnet, since the forward direction is positive, let's write them down. We have 390 in the forward direction, 395, plus 295 also in the forward direction. And since the friction force is in the opposite direction, I'm going to subtract 560 newtons. If we add this all together, this is going to give us 110 newtons left over in the positive direction. So now we have Fnet, we can solve for acceleration. Just to isolate our acceleration, getting it on one side, let's divide both sides by the mass to cancel it out on the one side. So Fnet over the mass is 110 newtons over 1,850 kilograms. Let's put that in our calculator. We get 0.0594. And that's going to round to 2 sig fig, 0.059 meters per second squared. Another unit you can use is newtons per kilogram. Okay, either units work. In the forward direction. Here's a chance for you to try the problem. you have a kangaroo sliding across the ice. It experiences a force due to friction. Calculate the rate at which the kangaroo is decelerating across the ice. So this is asking for acceleration. And hint, you've probably seen a free body diagram similar before. So here's a chance to pause the video, and I will come back to do the solutions in fast play. Alright, and here I go. Okay, first we're going to draw a free body diagram of our kangaroo, and yes, we do have the force of gravity pointing in the downwards direction, as well as the normal force. They balance out, and also we don't really care about that direction because the kangaroo is moving in the horizontal direction, which the friction force is holding it back. Fnet equals ma. Since we need to calculate for acceleration, we need Fnet, and there's only a force of friction acting along that direction, so let's first isolate for acceleration. Then our Fnet is just our force of friction dividing by our mass. We get the acceleration as such. Don't forget the negative sign because it's decelerating. Okay, and here we have the equation. Notice there was only one force that was affecting the kangaroo's motion going forward, causing it to decelerate at a rate of 0.28 meters per second squared. Okay, so thank you for watching this video. Hopefully you got a few skills. Tune in for the next video, which I'm going to do another problem and also plus a try it yourself. Fat Mama Physics signing out.